Hello and welcome back to Math 055. This is a video over section 7.8, and we're going to be talking about the complex numbers. Okay, now this is where it gets a little weird, and we have to use our imagination. Okay, so what we're going to talk about here is we have this web. Okay, where we talk about all the numbers, kinds of numbers that we have. Okay. And in our study, until you get to very, very advanced math classes, the main one that we talk about is the overarching complex number system, okay? Now, the complex number system is composed of real numbers. Now, a real number is any number, okay? It's any number you can think of. Rational numbers are fractions, integers are whole numbers, and they're negatives, and natural numbers are counting numbers. Irrational numbers are numbers whose decimals don't repeat or end. But then we have this concept over here of an imaginary number, okay? We're not going to get into what a pure imaginary number is, but when we combine real numbers and imaginary numbers, you get a complex number, okay? And we'll talk about how we get that. Now let's think about something here, okay? Before we do this example, solve for x squared equals -1, okay? What we could do, let's think about this. Let's say we take, like, say 3 squared, okay? And remember what that means. I'm going to take 3 times 3, and that's going to give us 9, okay? Remember that if we take the square root of 9, okay, it's going to bring us back to 3, okay? The other thing that we can say over here is that, if I take, say, -3 squared, okay, that's going to give us -3 times -3, and that's going to give us +9, okay? Consequently, if we take the square root of 9, okay, we can either get 3 or -3, okay? So that's kind of, what we've been doing. Now, here's the thing, okay? If I take some number here, and let's say I take, say, x squared, and that's going to give us 9, okay? And what we've been doing is we've been taking the square root of both sides to solve for that, and consequently, we think about, okay, what number could x be? All right, well, x could either be 3, okay, if I square that, that'll give me 9. If it's -3 and I square it, it'll also give me +9. So x could equal plus or minus 3, okay? Now, what I want you to think about is this. When we square a number, we get a positive number. So if you square, okay, you get a positive number, okay? And that's seen here and it's seen here. Okay, so squaring a number gives you a positive. But now we have this problem here, where I have an equation. If I take some number and I square it, I get a negative number. Well, that doesn't really work, okay, right? If I take some number and multiply it by itself, it's always going to give me a positive number. So this is a contradiction, okay? And what we have is we have to solve this, all right? But the understanding that we have to do is we have to let's go ahead and do this. Let's take the square root of both sides. Let me write this down here. X squared is equal to -1. Okay, if I take the square root of both sides, okay, I get that x is equal to plus or minus the square root of -1, okay, which is a number that we can't take the square root of, all right? And so we have to create a new number system. So in order to solve this, we created a new number system. Let me just do type of number. Okay, and that number is an imaginary number, okay, which leads us to that this is an imaginary number. All right, so let's think about this, okay? So we get this value here. Let me bring this up over here. And what I'm going to write over here is we're going to write that x is equal to plus or minus the square root of -1, okay? Now what I want to do here is come to the conclusion here, all right, and let's write this over here, that the square root of -1 is really equal to this imaginary number that I call I. Okay, this is very important that we know this, okay, and that you remember this, all right? So what I get here is I get this. I get that x is equal to plus or minus I, okay, when I take the square root of a negative number. So if it's one of those things you need to go back and rewatch this portion of the video, it's not a bad idea, okay? So that's what an imaginary number is, okay? It's something that has an I to it, all right? And let's draw an arrow here. Imaginary number I is equal to the square root of negative 1. All right, so, you know, and let's just kind of think about something. There's all this explanation of the stuff down here, and what I want to do is talk about, you know, what a complex number is. So a complex number, all right, let's write this over here. So a complex number is, and I use the pound sign or the hashtag symbol to say number, okay? So complex number is in the form, so in the form A plus BI, okay, where A is a real number, okay, and B is imaginary, okay? So when you put them together, all right, this A plus BI is a complex number, okay? And you know, that's it. You have a real component of it, and you have an imaginary component of it. Now, you're probably sitting there going, okay, Joe, how come we have these things called imaginary numbers, okay? And I'll tell you the reason why. The reason why is because we had to come up with solutions to this type of problem, okay, to this type of equation. So we created a new type of number. That's what we did. All right, and so in order for us to kind of wrap our head around that, and I'm not going to go very far into it, but it is used in a lot of electronics. Okay, a lot of electrical engineers when they're developing, you know, electric components of like a plant or a building or something like that, they have to use imaginary numbers. Okay, kind of weird. All right, but when you deal with anything with electronics, they involve that imaginary number system. It's heavily used in computing and computers, and so you know, something we just gotta kind of trust that this works. So, you know, and here the crazy thing is, you guys like all these, you know, you like these videos and all that stuff. Well, it's all used by electronic equipment. Okay, without you know, complex numbers, then this video would not be coming to you. So kind of a very useful thing that we have that we often take for granted. Okay, so the other thing I want to talk about, and I'm going to do this up here, and I really apologize about the lack of space up here. Well, let's say we know this, okay? If I take the square root of negative 1, I know that's equal to I, okay? So what happens if I square this number? All right, well, let's write that down here. Let's do... let's say I have I and I square it. That means that I'm going to take the square root of negative 1 and I'm going to square that. Okay, and if I take the square root of negative 1, then that just gives me negative 1. And then that's going to be equal to I squared. Okay, so we've got this first thing. I know what I is equal to, but if I take I squared, okay, it's going to give me negative 1. Now let's say I take I equals, you know, square root of negative 1, and let's say I cube that, okay? So what happens is I'm going to get, you know, the square root negative 1 times the square root of negative 1 times the square root of negative 1, and that's going to equal I cubed. Well, if I take the square root of 1 times, negative square root of negative 1 times the square root of negative 1 is just going to give me negative 1. Okay, times the square root of negative 1. And that's going to equal I cubed. Okay, so if I cube I also know that the square root of negative 1 is equal to I, so I get negative 1 times I, which equals I cubed. Okay, so I cubed then is going to equal negative I. Okay, so that's that. All right, now the last one I want to do, and I really apologize about the lack of space, but let's say I have I is equal to the square root of negative 1. Okay, if I raise this to the 4th power, all right, and raise that to the 4th power, then what's going to happen is I get I to the 4th is equal to the square root of negative 1 times square root of negative 1 times the square root of negative 1 times the square root of negative 1. Okay, and so as a result, what I'm going to get here, square root of 1 times square root of negative 1 times square root of negative 1, that's just going to give me negative 1. Times, if I do square root of negative 1 times the square root of negative 1, that also gives me negative 1. So I to the fourth is really equal to negative 1 times negative 1. If I take a negative times a negative, I get a positive. Okay. Now the cool thing is that this is going to be cyclical. Okay, this is going to repeat itself. So if I have I to the fifth, okay, so I to the fifth, that means I'm just going to have I. Okay. If I have I to the sixth, that's going to be negative 1. I to the seventh is going to give me negative I, and then if I do I to the eighth, I'm going to get 1 back again. So these things will pop up again and again, but I wanted to show you that. If you just got this part written down, that's good, but we'll kind of come back to this later in the notes. Okay, so let's go back through and let's kind of just jump in here. Okay, and what we want to do is perform operations with complex numbers. Okay, and so we just want to add these together. So the first one I've got is I've got negative 8 plus 4i plus the quantity 2 plus 6i. So I want to treat this just like I would like terms. Okay, so you know, let's just write here, this is similar to, okay, so similar to combining like terms. Let's get that written down and let's jump in here. Okay. All right, so if I were to do these problems, okay, you know, I have a real portion, okay, here, and then I have an imaginary portion here and here. Okay, so if I combine these and I'm just adding them, I'm just going to combine my real portions, so negative 8 plus 2, and then plus 4i plus 6i. Okay, and that's it. That's all we're doing. Okay, so combine your real portions, combine your imaginary portions, and we get a new complex number. So if I take negative 8 plus 2, all right, it's going to give me negative 6. And then if I take 4i plus 6i, that's going to give me a total of 10i. And that's my answer. Okay, and that's all we're doing. Okay, so pretty easy. All right, just got to make sure we understand what I means, because a lot of times it's rather confusing. All right, let's take a look at part B. Now, in part B, we're subtracting. Now, what we're doing is we're subtracting this negative here, okay? So we have to first distribute the negative, all right? So I'm going to take this negative here, and I'm going to distribute that on the inside and make all these other parts over here positive, okay? So I'm going to rewrite my problem, and let's write it as negative 2 minus 3i, okay? And then I've got minus subtracting negative 4, so that's really going to be a plus 4, and then subtracting negative 14 is really plus 14i. Okay, so again, we have our real component of negative 2 and 4, and then we have our imaginary component, which is negative 3i and positive 14i. Okay, so we can combine those together, so negative 2 plus 4 is going to give me a positive 2. If I take negative 3i plus 14i, that's going to give me plus 11i. And that's it. Okay, so, you know, we got to just be aware of our signs, just like as if we were combining like terms on any other type of problem. Okay, all right, so now, that's the first thing. Okay, now let's go back through and let's go through and simplify each of these and put them in terms of I. Okay, so again, you know, when you have the square root of a negative number, in the past we couldn't do that. Guess what? Now we can. All right, so you know, let's first do this, and here's why this works. If I take the square root of negative 64, I can split that up into the square root of negative 1 times 64. Okay, I can do that. Now what I do is I can just go, okay, well, this is really the square root of negative 1 times the square root of 64. Okay, and so if I take the square root of negative 1, remember that that number is I. Okay. And then the square root of 64, I know to be 8. And so now I have this complex number here, which is 8i. Okay, and you can leave it like that. If you wanted to put it in a true complex form, you do 0 plus 8i. But you don't have to do that, okay? That's something that is, either one works, but this one works just fine, okay? So the other thing is you just kind of think, all right, if I take the square root of 64, I get 8, and because it's negative, I got to put the I in there. So you don't have to do this every time. Feel free to do that, but you can kind of just jump from this step to this step if you understand the concept, all right? Take a look at part B. Part B is square root of negative 18. Now, I can't take the square root of that, so let's break this one up because we're going to need to. And let's rewrite this as a square root, put my negative 1 out here, times the square root of 9. So let's put 9 and then 2. So if I take, why I did this is because I can take the square root of 9, okay? 9's a number that goes into 18. So what I can now do is take a look at it like this and do the square root of negative 1 times the square root of 9 times the square root of 2. Now I can take the square root of negative 1, I can take the square root of 9, all right? And that's going to give me 3i, okay? And then times the square root of 2. And that's my final answer. So we're just simplifying these, all right? Okay. So this portion here is for the examples on the next page. So we're going to perform the operations and simplify in terms of I if necessary. All right, so we're just going to perform these operations. Now, these are a little bit different, so I'm going to take, just do what it says. All right, so if I've got, taking the square root of negative 3 and the square root of negative 5 and multiplying these together, then what I'm going to do is I'm just going to take what's inside and do square root of negative 3 times negative 5. Now, what that gives me is, I get a positive number out of this. A negative times a negative gives me a positive, so this is going to give me the square root of 15. Now, unfortunately, I can't take out a square root from that, so this is just where I leave it, okay? Now, what's kind of nice about that is I got a positive number under my square root, so I don't have to convert it to I or an imaginary number, so it's kind of nice. Okay, let's take a look at part B. Now, this one's a little bit different. So what I notice about this one is I've got the square root of negative 7 times 7, okay? So let's just write it all as one square root. So I'm going to do square root of negative 7 times 7. And this is going to give me the square root of 49. Of negative 49. So, from that, okay, now I split this up. Now I go, okay, if I've got the square root of negative 1 and then times 49. Okay, so I usually kind of split that up, and I'm just going to go, okay, if I've got square root of negative 1 times the square root of 49, I can take the square root of both, and this is going to give me I times 7. And usually when we write this, we write 7i as a result, and that's our answer. Okay? Okay, let's take a look at the next one. Now, part C, all right, now we're dividing two radicals. So I'm taking the square root of negative 56, and I'm dividing that by the square root of negative 7. And what I want to do is write this as a single fraction. So I'm going to do the big square root of negative 56 divided by negative 7. And if I take a negative, and I can now simplify this part inside of my fraction. So I can do negative 56 divided by negative 7. That's going to give me the square root of positive 8. So I don't have any negatives anymore, which is nice, okay, but we can still simplify this. Because a perfect square that goes into 8 is 4. So I can rewrite this as the square root of 4 times the square root of 2. Okay, square root of 4, I can do that. That's going to be 2. And then times the square root of 2, and that's it. Okay, and that's my answer. So, yeah, you just want to be able to look at a problem and do the math and see what happens. Okay. All right. So now what I want to do is I want to perform multiplication. Okay. So find the products, meaning I want to multiply these together and express our answer in the form of a complex number. So here's what I've got. All right, so when I do this, I is a number. Okay, I'm just going to treat it like another number. Really what I have here is I'm doing 7 times the imaginary number I times negative 6 times the imaginary number I. And what I want to do is just multiply my numbers and then multiply my i's. Okay, so if I take 7 times negative 6, it's going to give me negative 42. Okay, and if I take I times I, that's going to give me I squared. Okay, and if we remember from the first page, okay, so let's remember, all right, remember this, okay, square root of negative 1 is equal to I. Okay, if I square I, that's going to give me negative 1. Okay, remember if I cube I, that's going to give me negative I. And if I raise I to the 4th, it's going to give me positive 1. So here's what I got. Okay, I've got negative 42 times I squared. Remember, I squared is equal to negative 1. So my next step here is to take negative 42 and multiply it by a negative 1, and that is going to give me positive 42. Okay? All right, let's take a look at the next one in part B. In part B, we have 7i times negative 9 plus 3i. And what I'm going to do is I'm going to distribute this, okay, into each of those. So here I've got 7 times I times negative 9 plus 7 times I times 3 times I. All right, and so what I have here, all right, I'm going to just multiply my numbers here and here. So 7 times negative 9 is going to give me negative 63, and just multiply that by I. Okay, then over here I've got 7 times 3, so that's going to be plus 21, and then times I, which is I squared. Now what I know is that I squared is equal to negative 1, so I'm going to do negative 63 times I plus 21 times negative 1. Okay, and so what I have is I have negative 63I plus, or rather it's minus 21. Okay, now if I wanted to put this in true complex form, what I would do is I would take negative 21 minus 63I, and I would just leave it like that. Okay, and that's in complex form. Okay, now over here, okay, I've got these two what look like to be binomials, all right? And what I want to do is I want to FOIL these. I want to multiply them out. Now you can use FOIL method, you can use box method, kind of whatever you want. I'll go ahead and use box method on this. I don't historically use box method with imaginary numbers, but I think it's good practice to start. So I'm going to do 8 minus 4i here, and then I'm going to do 7 minus 2i. Okay, so now what's going to go in this box, 7 times 8 is going to give me 56. Okay, and then if I take negative 4i times 7, multiply your numbers, keep the I there, this is going to give me negative 28i. Okay, now over here I'm going to take 8 times negative 2i, which gives me negative 16i. And then if I take negative 2i times negative 4i, negative times a negative is a positive, so this is going to give me positive 8. But then I want to take I times I, which gives me I squared. Okay, now let's write all this down here. And when I write this, I'm going to write 56 minus 28i minus 16i, and then plus 8i squared. Okay, so when I do this, the first thing I want to do is address the I squared issue. Okay, and so now I've got 56 minus 28i minus 16i, and then plus 8 times negative 1. All right, so really that's just going to become negative 8. All right, so let's do 56 minus 28i minus 16i minus 8. Okay, so now what I want to do is combine my like terms. Okay, and my like terms are my numbers, 56 and negative 8, and then my imaginary numbers are negative 28 and negative 16i. Okay. So if I just combine my first like term, 56 minus 8, what is that going to give me? 48. Okay, so this is 48, positive 48, and then negative 28 minus 16i is going to give me minus 38. Okay, which is going to give me negative 44i, and that's my imaginary number. Okay, so when I multiply two imaginary numbers together, I'm going to get another imaginary number. All right, so pretty cool. All right, on this last one, it's got I to the 11th power. Now, remember what I know. Okay, remember this is where this comes back into play. I is equal to square root of negative 1. If I've got I squared, it's going to equal negative 1. If I have I cubed, that's going to give me negative I. And then I to the 4th is going to equal positive 1, okay? So let's think about what we can do here. Now, what I want to do is split this up. I want to rewrite I to the 11th. Now, what I want to do is I want to get something with an I to the 4th, okay? So what I'm going to do is this. I'm going to do I to the 8th, and I'm going to raise that. Right, no, I don't want to do that. And I'm going to multiply that by I to the 3rd power. Okay, and the reason why I did that is because, I'm just using my law of exponents. I'm using that concept where I'm taking, if I were to combine these two here, all right, I would do 8 plus 3, and that would give me 11. So I'm going backwards. Okay, now I to the 8th, I can rewrite that as I to the 4th to the 2nd power, and then times I cubed. So what I end up getting, the reason why I want to get this into something I to the 4th is because I to the 4th is equal to 1. And what that does is I can then replace I to the 4th with 1. Okay, I'm going to square that and then multiply it by I cubed. So 1 squared is just 1. Okay, and then multiply that by I cubed is just going to give me I cubed. Now remember, I cubed is negative I. So this is equal to just negative I. Okay, so if I were to just do I to the 11th, I get negative I. Okay, so there's that. All right, the last one. What I want to do in this last one is I want to find this quotient between negative 5i and then 2 minus 4i. Okay, and what I want to do is I want to do the same thing that I did when we rationalized the denominator. And to simplify these, we want to multiply, okay, the top and bottom by the conjugate. Okay, and so remember the conjugate, okay, so let's remember this concept, okay, if I've got a plus b times a minus b, those are conjugates, okay, and the result of multiplying those together is just going to give me a squared minus b squared, all right, so that's what we got to keep in mind here. All right, so negative 5i over 2 minus 4i. So what I'm going to do is I'm going to multiply, okay, the top and bottom by the conjugate of 2 minus 4i, and that's just going to give me 2 plus 4i, okay? I'm going to do that on the top and on the bottom. All right, now what you can do is you can use the formula if you're familiar with the formula, or sometimes it just helps to just keep multiplying it out. So my next step is going to be this. I'm going to do negative 5i times 2 plus 4i. Okay, I'm going to leave that up there. Now, down below, okay, I'm going to do my multiplication. So I'm going to do 2 times 2, which is going to give me 4. Negative 4i times 2 gives me minus 8i. 2 times positive 4i gives me plus 8i. And if I do negative 4i times positive 4i, so I'm going to get negative 16. Negative 4 times positive 4 is negative 16 times I squared. Okay, and that's going to be my whole denominator. So now what I want to do is kind of, just do the next steps. All right, so the first thing I want to do is distribute my negative 5i into both. So negative 5i times 2 gives me negative 10i. Okay, negative 5i times positive 4i gives me minus 20i squared. All right, and we're going to divide all that by 4. And here's the cool part. Okay, here's why we multiply by the conjugate. Because these middle terms here are going to cancel out. Negative 8i plus 8i, that's just going to add to 0 and cancel out. Okay, so therefore, what I get is I get minus 16 times negative 1. Okay, that's that step. Okay, now the next thing I want to do is I'm going to do this part, which is negative 1. So I get 10i minus 20 times negative 1. And we're going to divide that by 4 minus negative 16. Okay, so here's what I got. All right, so I've got negative 10i plus 20 divided by 4 plus 16. Now, when I do that, okay, here's what I got. All right, I'm going to put my 20 out front. 20 minus 10i all over 4 plus 16, which gives me 20. Okay, so now here's kind of the cool part. All right, you can probably, this is done, essentially. okay? But what I want to do, because I have, I'm adding and subtracting two things in my numerator, I'm going to put that over the same denominator. So I'm going to do this. I'm going to do 20 over 20 minus 10I over 20, okay? And the cool thing is I can simplify this. I can write 20 divided by 20 as 1, and then minus 10 divided by 20 is going to give me 1/2, and then I. And that's my answer, okay? So either one of those would be fine. I'd probably prefer to have it simplified, but that's the idea, okay? So that's it for the notes. I know this was a very long section of notes, but there's a lot to do here. There's a lot of information. So again, guys, I apologize about the space on the first page. If you have space down here, you may want to go back through, rewatch that part, and write that part down here. So hope you enjoyed this. Let's go ahead and get started on your homework. Thanks a lot.